All right, all right. Welcome. This is lesson number 4 on factoring. So this topic we're going to talk about is how to factor by grouping. So this lesson I could already tell should maybe take anywhere between 25 and 30 minutes for me to fully explain exactly how to do this concept. In your Algebra 1, you should have probably learned about this, but whether or not you fully understood what you were doing, I don't know. But let's just assume that we're starting from scratch, okay? So I'm going to do my best to explain this concept of factor by grouping, okay? So you have to be very patient, and I will go over all the problems step by step with you. All right, so let's actually introduce, like, what does this concept of grouping mean? So let's go back to our old technique, our old friends of FOIL and distributive property, right? Let's say if you wanted to multiply these two binomials using the FOIL, right? What do? You do y times x and then y times 4, right? And you get yx plus y4, or just 4y, right? Remember, you have that y times x is yx, and y times 4 is that 4y, okay? Now, this is using FOIL, okay? But what if we were to use a distributive method? For those of you who are not, usually if you see two binomials like this, almost 99% of the time you always use FOIL. But you can also distribute this. And how would you do that? You would take that y, right, and multiply that y times this whole entire binomial. So it would be y times x plus 4. It would be y times x plus 4. Okay? And if you just think about it for a second, this yx plus 4y also has to equal this, which it does. Y times x is yx, and y times 4 is 4y. So far so good. Now let's continue on. Let's say now we go back to FOIL. If you do y times x and then y times 4, what's the next move? You look at that negative 3, what do you do with it? You do negative 3 times x, which is negative 3x. And then you do negative 3 times 4, and that's negative 12. Okay? Now let's jump back to distributive. Originally, we took that y and then multiplied that y times x plus 4. That x plus 4. Now, what do you think you're going to do? You're going to take that minus 3 and multiply it by x plus 4. So you're going to multiply minus 3 times x plus 4. And notice that it'll be the same, because minus 3x minus 12, we need to get that, right? Because I feel like you really trust the FOIL here. So used to FOIL. But this also works, the distributive method. So negative 3 times x is negative 3x, and negative 3 times 4 is negative 12. So it works out. So let's say, for example, if you have this, right? What I want you to do is use only the distributive method to set this one up and set this one up, okay? What would it be? What would this look like if you were to do z minus 5 times x plus 2? What do you do first? You take that z and multiply it by x plus 2, right? So you get z times x plus 2. Then what do? You take that minus 5 and multiply it by x plus 2. So you get minus 5 times x plus 2. Okay? And what about here? If you have g plus 6 times p minus 4, pause the video and see what it would be like. Okay, what would it be like? Let's say you unpause the video, you take that g, you multiply it by p minus 4, and you get g times p minus 4. And what's next? You do 6 times p, plus 6 times p minus 4. And you're thinking right now, Mr. G, wait a minute, Mr. G, why aren't you actually solving this whole entire thing? This, yx plus this whole thing, like, why aren't you solving it out? That part is not that important right now. We're not trying to solve anything right now. We're just trying to get a rhythm of what it looks like. Now, let's say, for example, we wanted to go backwards. So instead of like doing this z times x plus 2 and this negative 5 times x plus 2, what do you think it would mean? Let's say if we just had this, right? Let's say if you just had this. What would be the two binomials that when you multiply them give you this. That give you this, right? This is just equal to, you see that's z minus 5, you combine them together. And it's this x plus 2 is common. And it's just that, right? They're just the same thing. If we did the same thing here, if we're trying to go backwards, what do? You take that g and that positive 6, you put it together, that g plus 6, and you just, the p minus 4, it just goes there. Okay? What I'd like you to do is, looking at the next ones, try and go backwards. What would be the two binomials? Okay? We'll do the first one together. Pause the video if you want, take a quick second at it. Let's say you pause back. Remember, you just, the same thing we did here. Look, you take that g and that plus 6, and you put it here. We're going to do that as well here. You're going to take that y and that minus 7, group it together, that's y minus 7, and they have that p minus 4 is common, and it just goes there. And you're going to do the same thing here. That x plus 3 is common. You're just going to put it here. And that's it. What about this one? Are these two the same? That a plus b and a plus b, do they have a common binomial? Do they have a common? They do. It has a plus b, so we could use that a plus b. And then what would be in this binomial? You just take these two guys. You have an x and a minus g, so it's just x minus g. What about this one? Do they have the same binomial? Yeah. So you take that x plus 3, and you have that 2x minus 10. Okay. What about this one? All right. Pause the video and try and do these two. Okay. 3, 2, 1. Let's say you paused and came back. So what did you get? You should get 6x cubed plus 10x. Group it together, and the other x plus 5 is common. Now what about this one? You have 3x squared and 7x. You're thinking, okay, I could put it there, but then I have x plus 3 and x plus 4. Oh no, what do? You cannot group these. Oh, whoops. You cannot group these. Okay, so this is just a no-go. You can't group them together. If you wanted to evaluate this, you would have to just be old school, just do 3x squared times this, 3x squared times that, 7x times this, 7x, whatever that is, and just, you get some sort of mess, and then you combine everything together, right? So this idea of going backwards will be very important by factor of grouping, okay? You've seen this before, FOIL. I don't know how many of you have actually done distributive method of this, but let's say you didn't know, now you know, and how will that help us? Let's go to the next paper for our, oh god, where is everything? Ah yeah, it's over here. Okay, let me organize notes. What I'd like you to do is, here are the steps for factor by grouping. Okay, that's better. What I'd like you to do is, before we actually start, pause the video and write these notes down, okay? Write them down, and we're gonna go step by step. This should be step 1, step 2, step 3, okay? And I'll explain everything, right? So let's say you let's say you wrote everything down. Let's go over this question together. What's the question saying? We have this, oh god. Zooming is my worst enemy. My god, I'm terrible at it. All right, so let's say we have this, right? We have this this is the question. We have 2x cubed minus 3x squared plus 4x minus 6. Now, we want to factor this polynomial, right? It has, how many terms does it have? 1, 2, 3, 4, right? We want to put it into some sort of binomial, right? Into two binomials. So let's see. What is the first move? What are they telling you to do? The first move is group the first two terms and the last two terms. Put them in parentheses. So if we look at this 4 terms, right? What are the first two terms? It's this guy and this guy. So what do? They grouped it using parentheses. Now, what is the next thing they tell you to do? And the last two terms. So you do 4x minus 6. You group them together, and you put parentheses around them. Okay? So that's all you're doing. You're just doing parentheses here, parentheses here, parentheses here, parentheses here. That's it. That was this step here. What's the second move? It's telling you to factor out the GCF from each group. Okay? This is a group. This is the first group. This is the second group. Whoops. This is the first group. This is the second group. What is it telling you to do? It says factor out the GCF. So what is the GCF of 2x cubed minus 3x squared? Well, let's see. What's the GCF of 2 and 3? It's just 1, right? So you can't really factor anything out. But what about x cubed and x squared? If you go back to finding the GCF, remember, you always do, if you have two variables, smallest exponent. So it's x squared. So notice, when you factor out that x squared, what is 2x cubed divided by x squared? This is from lesson number 2, okay? If you feel like you're a little shaky with finding the GCF and factoring it out, I suggest you pause this video and go to this lesson, but yeah, and then come back to this. But let's say if you're good with it and you want to keep going on, notice that when you take that GCF, what do you have to do with the GCF? You have to divide everything by the GCF, right? And then put that GCF over here. What is 2x cubed divided by x squared? That's 2x, right? 2 divided by 1 is just 2. X cubed divided by x squared is x. And then what about this guy? Negative 3 divided by 1 is just negative 3. And x squared divided by x squared, it just cancels. So then this group is just equal to this expression. And what about here? What's the GCF of 4x and minus 6? Well, the GCF of 4 and 6 is 2. And x, well, they don't have x in common, so you can't take it out. So this is divide by 2 and divide by 2. And then 4x divided by 2 is 2x. And negative 6 divided by 3 is negative 3. And then you get this. And then look what happens. What do we have? Notice that 2x minus 3 and 2x minus 3 are the same. What can we do that we did before in these examples? That if they were the same, you can group them like this, right? Here, let me zoom in again. Oh, zoom out. Remember, you see these two are the same. They're common. You put them together, you put it over there, and you just take these two guys and put it over there. And that's the same thing you're allowed to do over here. These two are the same, so they become, oh, whoops. These two are the same, and they go here. And that x squared and that positive 2, they go right there. And voila, you did it. Factor by grouping, okay? What I'd like you to do is try and do these two questions to warm up, right? Following the steps. Follow the steps you wrote down. Follow the last problem. Try and work on these two questions. Oh, whoops. Yeah, okay. Do this question factor by grouping and this question factor by grouping. What I'll do is I'll pause the video. I mean, not me. What I want you to do is pause the video, try your best, try and solve this and see what you get. Okay? So let's say you pause the video. Let's say you did it. Now let's actually go through the solution. So step by step, what is the first move? You know, from your notes that you just wrote down. If we look at this question here, you group them. You take the first two terms, group them, put a parentheses. You take the next two terms, put them in parentheses. Then do what? You're going to take out the GCF. What's the GCF of 2x cubed and 3x squared? It's x squared. And if you divide this by x squared, what do you get? You get 2x. And if you divide this by x squared, you get minus 3. Okay. And what about this one? What's the GCF of 8x and negative 12? It's 4. So you put it's a positive 4. You're going to take a positive 4 out. So now this becomes 2x minus 3. And notice that these two are the same. So we're allowed to group them. So you have 2x minus 3. And then it's these two guys over here. It's x squared plus 4. Okay. So this one was a pretty straightforward one. It was very similar to the other one. If you had any questions, I think it would be about this one, and there's a reason why. But let's try and do this question together. And hold on, just to go back a little bit. Remember, what's the goal? What's the goal when you're factor by grouping? You have this polynomial, and you want to put it into two terms. Into two binomials. You have this polynomial, 4 terms, and you're going to put it into two binomials. All right? Now let's look at this one. Let me move this. Okie dokie. What's game plan 1? Parentheses, parentheses. And careful over here. Remember, you're including that negative in the parentheses. Parentheses, parentheses. So, what's the GCF of 3y cubed and minus 4y squared? It should be y squared. And if you divide the y squared by this, you get 3y. And divide the y squared by this, you get minus 4. Now, I'm going to pause you. I'm going to tell you to pause and think about this for 1 second. If you have this 3y minus 4 over here, what must you get over here so you can do this little factor by grouping? You need to get another 3y minus 4 over here, okay? So do what you can to try and get a 3y minus 4 over here. Now, let's look at this. If we have negative 6y plus 8, and you think to yourself, oh, Mr. G, the GCF is 2. And you're 100% right. The GCF is 2. And if you take out 2, what do you get? You get minus 6 divided by 2 is minus 3y, and this is plus 4. And then you're like, crap, wait a minute. This is not the same as this. So what do we do? Did we do anything wrong mathematically? There was nothing wrong mathematically. You obeyed the rules of math. But the thing is, instead of taking out a 2, let's try and take out something so we can get something that looks like 3y minus 4, because we're very close. We don't have 3y minus 4. We have negative 3y plus 4. We have the opposite signs. We have opposite signs. So the trick is, instead of taking out a positive 2, take out a negative 2. Okay, take out a negative 2. And if you divide negative 6 divided by negative 2, you get a positive 3. You get that positive 3y. And positive 8 divided by negative 2 is negative 4. And then voila. They are the same now. They are the same. So here it's a minus 2 times 3y minus 4. And then your life is very easy. These two are together. You have y squared minus 2 and 3y minus 4. And now you're happy because these two are the same. You had a polynomial of 4 terms and you grouped it using 2 binomials. Okay, big happy face. The only way you're going to get better at these is by practicing. Okay, the only way you're going to get better at these is by practicing. So what I have is, here are 4 questions that we did in class, and let's see. These are 4 questions we did in class. What I want you to do is try and do these questions by yourself. How are we doing on time? 18 minutes, 30 seconds. Okay, so try and do these 4 questions by yourself, and I'm going to make another video showing the solutions. Also, I didn't show this to the other classes yet, but if you want, why don't you practice these questions, okay? You could also practice these. So, oh, whoops, no way. Only practice these questions. So, 1, so this is a good question to practice. Number 1, number 2, number 3, number 4, number 7, number 10, number 11, 12, 13, and 14. Okay. So 1, 2, 3, they're right over there. You could pause the video and just write it down. Here are the other questions. 7's a good one. 10 is a good one. 11, 12, 13, and 14, they're also good. And if you're thinking, Mister, why can't I do 9, 8, 6, and 5? There's a technique I need to show you before you know how to do 5, 6, 8, and 9. You could try and do them, but you might get stuck, and there's something that you have to do before you do them. But try and do those questions. I'll make another video showing the solutions for not all of these. That will make me go crazy. I'll probably just show the solutions for 1, 2, 3, 4, which we did in class, but I'll show them again. And maybe like 1 and 2 over here, just so you get a feel for it. And if you want, you can, I'll show you the solutions for the other one so you can try and do it on your own, okay? All right, so I'll make another video about that with the solutions.